Okay, graphing linear inequalities. So to graph a linear inequality, here's what we do. First of all, graph the linear equation as if it were just an equal sign. Then, instead of drawing a solid line, we have to determine if the line's going to be solid or dotted. So if it's less than or greater than, the line you draw is a dotted line. If it is greater than or equal to, less than or equal to, or greater than or equal to, then you can keep it as a solid line. And that's simply a dotted line shows that that's a boundary. It doesn't include that line, but it goes right up to it, and a solid line includes that line as well. And step 3 is we test a point away from the line, and one of two things is going to happen. Option 1 is the point is actually part of the solution, and that'll happen if when you test that point you get a true statement. I'll show you what that means in a second, and we shade in that area. If the point tested is false when it's substituted into the equation, don't shade that area, shade the other side of the line. Okay, let's take a look at this through a couple of examples. 2x plus y is less than or equal to 4. So again, think about this equation. Instead of being less than or equal to, just think about it being equal to, and then I would write it in the terms of y equals mx plus b, just because it's a little easier to work with. So y equals negative 2x plus 4. We can grab some graph paper and graph this. So it's got a y-intercept of plus 4 and a slope of negative 2, down 2 over 1, and that pattern continues. And up 2, back 1, that pattern continues. Next step is you determine whether or not it is a solid or a dotted line, and greater than or equal to, like less than or equal to, both of these are going to be a solid line. So we just connect the dots like we would normally, and just reuse a ruler, draw arrows to the edge of the Cartesian plane, and now we test a point. And so I'm going to test the point 0, 0. And so when I do that, I put 2x plus y is less than or equal to 4. I take that original inequation and I substitute 0, 0 in for x and y, and I look to see what I get. Well, 0 is less than or equal to 4. Since that's a true statement, then 0, 0 is part of the solution, and this side needs to be shaded in, because all points on this side of that line will be solutions. And that's all there is to graphing linear inequalities. Let's take a look at another example. So we'll graph x minus y is less than 5. And so think about that as it's equal to 5, and then put this into y equals mx plus b. So if I subtract an x, and then I switch all the signs or divide by negative 1, I get this equation. So when I graph that equation, I have a y-intercept of negative 5, and I have a slope of 1, and in this case I have a dotted line. So just make it look like a dotted line. Still go to the edge of the plane and add arrows and test a point. So 0, 0 is really nice if you can test it if it's away from the line. 0 minus 0, is that greater than 5? Is 0 greater than 5? No, that's false. So this is not part of the solution, which means the solution is on the other side of that line. Okay, let's take a look at a little bit more complicated question. And in this case, we're going to take a look at how we can find the solution to a system of inequalities. And so my inequalities system is going to be x minus y is greater than or equal to 4, and x plus 2y is greater than 4. So what I have to do here is I need to graph both of these. So let's start by graphing x minus y is greater than or equal to 4. So I think about it as just an equal sign, and solve for y, dividing everything by a negative. And so I have minus 4 with a slope of 1, and this is a solid line. So it goes up this direction and down in this direction. And I can test 0, 0. 0 minus 0, is that greater than or equal to 4? No, it is not. So this one has a solution that's over on this side. Okay, now I'll graph the other one in green. So I think about x plus 2y equals 4. So that's 2y equals minus x plus 4, or y equals divide by 2, negative 1/2, and divide by 2, 2. So there's 2, and it's rise and run, rise, run, rise, run. And so it goes across like this. And this is a dotted line. So let's make it that. And again, it's away from 0, 0, so I can test 0, 0 into the original equation. 0 plus 2 times 0 is greater than 4. Is 0 greater than 4? No, it's not. So the solution goes in this direction. And now you'll see that there's an overlap. So this line here and this dotted line here are the boundaries, and this area here was both blue and green, and it continues in that direction. And that red area is the solution area. So the easiest way to show it is to use different colors, or you can kind of see I used different directions for my blue and my green, and I got kind of a crosshatch in the middle. Just shade in really darkly the final area of solution. And so any point that's in here will work. So this point will work because it's on this line. A point like this will work. This point is a solution. Points on this line, this dotted line, are not solutions because it doesn't include the dotted line. But there's lots of points that are solutions. If you tested any of those black things, black points, into these two equations, they would hold true for both equations. And that's all there is to graphing systems of inequalities.